our planet and decrease the risk of Earth being hit by an asteroid. Co-founded by Carl Sagan and led today by CEO Bill Nye, the Planetary Society exists for those who believe in space exploration to take action together. So join the Planetary Society and boldly go together to build our future.
We're back. Not far from Lindy in that clean room was another leader of the Psyche mission.
Henry Stone, and I'm the project manager for Psyche here at JPL.
And part of this terrific team that we were just talking with Lindy about.
Yeah, it is an absolutely fabulous team, and I've been honored and blessed to be able to be chosen to kind of lead that team to the extent that it needs leading, because they do a great job on their own. But it's fabulous. We're building, as you can see here, a really incredible, sophisticated spacecraft that's going to do some really one-of-a-kind science and exploration of a body, as Lindy was surely telling you, we've never been to and know very little about. So no matter what we find, it's going to be scientifically exciting and interesting.
It is an absolutely gorgeous spacecraft. And as I said to Lindy, much bigger than I thought it was going to be for what it's doing.
It is much bigger than a lot of people think it is, in part because we decided to leverage the bus from a commercial satellite made by Maxar spacecraft that they use for ComSats and their whole electric propulsion system, and then merge that with the deep space capabilities that we have here at JPL. A really unique and new arrangement that we put together here for NASA to fly this mission. So we didn't try to over-optimize the size, because then we'd have to start from scratch. And we had a great starting point with the Maxar bus.
It sounds like the kind of approach that other people might want to try and emulate. Take a bus for commercial purposes and put some great instruments on it.
Absolutely. But you have to do that carefully, because depending on where you're going deep space, you got to make sure that that bus, in fact, is compatible with where you're going. And it turns out it worked out really well for this particular mission. Hopefully it will for other missions as well.
So what is the current status of the spacecraft? Are we looking good for launch in August?
We are looking good. We are in the tail end of system integration and test, what at JPL we refer to as ATLO, which is Assembly, Test, and Launch Operations. So we are just wrapping up in the next 2 weeks the activities here at JPL in this wonderful clean room here, getting the spacecraft all buttoned up after all the testing that we've been performing for a year and a half, and integration activities. And we're going to ship it at the end of this month. We're going to get it out to March Air Force Base in a shipping container, get it on a C-17, fly it out to Cape Canaveral. Once we get to Cape Canaveral, we're going to do some final testing and closeout activities there, get the solar arrays put on, and then we do the integration of the spacecraft onto the launch vehicle. We're going to be launching on a Falcon Heavy from SpaceX. That's excitement as well. We should be ready to go in August for our planetary launch.
Ever seen a Falcon Heavy launch? I did, because we were there for the launch of our light sail, which did not, a 3-unit CubeSat, it didn't need a Falcon Heavy, but we got a good free ride.
Yeah. I personally have not seen a Falcon Heavy.
Spectacular.
So this will be my first one. So the fact that I get to see that for the first time around and watch our baby.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Gagan.
Hi.
We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links, or head over to our YouTube page, YorkU Observatory, to join the chat. We will be monitoring the OPV chat room for questions and showing some live images from our 1-meter telescope. We've been blessed with amazing clear skies for nearly a week, so we'll be taking advantage of those tonight and showing you some great live images from our 1-meter telescope. For any questions or comments you may have on our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. And you can always contact us on Twitter or Instagram with the handle @YorkObservatory, and on Facebook at Alan I. Carswell Obs. So how are you doing tonight, Gagan?
Great. How could I not be with weather like this?
It's been so nice to actually have clear skies, because Toronto weather in April is just so horrible, and we go weeks without observing anything. So it's really nice to finally have some clear skies.
Yeah, we had a really gloomy period in April, so I'm glad we're moving past that. It's even warmer than usual, so really a great time to be up in the domes.
Oh yeah. A lot of the time when we've been observing late, we've had to worry about the dome because it has trouble with the cold. So yeah, there was a bit of time where we had to go up there, and before we would observe, open and close it a couple times to knock any snow and ice off. And sometimes even we'd have to interrupt our observations every half hour to open and close it to make sure it doesn't get stuck open. But it's really nice now. We open it at the start of the night and close it when we're done, and we don't have to worry about anything in between. So clear skies and warm weather, and everything's happy.
Yeah, ice on the domes, the joy of observing in cold weather.
Yeah. It also doesn't make noises as bad as it does when it's cold out anymore.
Yeah. Although I have to say I do prefer winter skies.
Oh yeah. That's the one thing that kind of sucks, is that it's only getting dark at like 8:30, 9 o'clock, and we can only start observing now. But so I will say that I like the winter skies a lot better for that.
Yeah, you ever wonder what it would be like to observe somewhere like equatorial?
Oh man.
Just warm all year round.
Yeah, that would be nice. But we're getting some great observations on both telescopes tonight. The 60 centimeter had been out of commission for quite a while, not because anything bad happened, but it just been a long time since we were able to get a good night of observation with that, and we've had a couple. So I think everyone at the observatory is very happy with the way that things have been going with the telescopes.
Yeah, I heard it was recalibrated and much easier to use now.
Oh yeah. It was. They had someone come up here to take a look at it, and they reweighted the telescope. So if you open up like the back of the telescope, you can actually grab the RA control and move it by hand, which is so cool.
Yeah, great for a several-ton telescope.
Yeah, and now that it's reweighted, it doesn't make as many screeching noises when you move it.
Yeah, those were always the worst thing about moving that telescope. It takes forever and screams at you the whole time.
Yeah. And whenever I used to train someone, I'd have warn them ahead of time, you're going to press the button and it's going to make a horrible noise, but don't worry, that's normal, and we don't have to do that anymore.
Yeah, I'm glad.
Yeah, well, we should probably get started with our This Week in Space and Astronomy history. So, Gagan, you're up first.
Yeah, so the first thing I want to talk about this week is the lunar laser missions, or the lunar laser projects. So the speed of light can tell us a lot. It's a known value. It doesn't really change. And it's, while measuring at light speed is difficult, you're, way down in the order of not negative, but really tiny fractions of time. Measuring that time it takes for light to reflect or travel somewhere and come back is a great way to measure distance. And the measure of the distance between the moon and Earth is actually one of the biggest ways we can see this application. So the measure of the distance between the moon and the Earth was attempted, revised many times over many centuries, and one of the most reliable measures developed in the 60s and 70s resulted from the lunar ranging experiments. So laser ranging is how distances are measured using laser pointers, and the lunar ranging experiments use laser pointers to determine the distance between the Earth and the moon. Lasers are basically light-emitting devices that emit light at a specific wavelength, and their reflection can be useful since we look at the specific wavelength they emitted and try and measure that wavelength as it's reflected back at us, and it'll be the same wavelength there and back. The very first lunar ranging experiment, which was referred to as the Lunar Sea Project, was actually not really an experiment to calculate the distance of the moon. See, the same principles that apply to lunar laser ranging also apply to radar, and we actually used radar to determine the distance between the moon and the Earth in the 50s. But the Lunar Sea mission actually sought out to see what the capabilities of lasers were and whether lasers could be used as a more effective way to measure distance, or whether they'd be able to, get to the moon and come back. So previous measurements of lunar distance were all done by, like I said, radar or optical angular measurements, and they were already pretty accurate. So we already had a pretty good idea of the distance the moon is and how that distance changes because the orbit isn't perfectly circular. So regardless, a research group at MIT led by Louis Smolin and Giorgio Fiocco, they pointed a laser at the moon and accurately used the reflection time to measure the distance between the moon and the Earth. And this successful measurement basically proved the prowess of lasers and their measurement capabilities, and kind of opened the doors for lasers to be used as a measurement tool going forward in all types of physics-related sciences and even in other scientific applications. Over the next few years, the Apollo and Soviet missions placed optical reflectors, which are, basically mirrors, on the surface of the moon to improve measurement accuracy. And we still use these mirrors today to determine the distance from the Earth to the moon. And the reason we do that is because the moon is steadily but slowly moving away from the Earth. So every once in a while, we have our researchers who point their lasers at the moon, point them at the laser reflectors, which are at very known locations, and they collect data on the time that it takes for them to get their reflections back. And we can do this because they're all around the Apollo landing sites, so it's pretty easy to figure out the location, and if you have a pretty accurate laser pointer, you can yourself calculate the distance between the Earth to the moon. So this first observation by the group at MIT was done 60 years ago today. So that's a fun time, and it was published in Nature. So pretty big discovery at the time, since lasers were a really new invention and led to a lot of it opened a lot of doors for further science.
Wow! So the first one, they just bounced a laser like right off the moon. They didn't use any of these reflectors or anything?
Yeah, so the first one was, it predated any of the lunar landing missions.
Yeah.
So they just, shot a laser at the moon, and I guess they didn't get a lot back, but they got enough to calculate the distance at a pretty accurate level. And they just reflected it. I think they picked one of the smoothest parts of the moon they could find with the highest albedo, and then used that to reflect their laser.
Wow.
Yeah.
I didn't realize that they could just do that right off the surface of the moon. Like I knew they had those reflectors up there from the Apollo era, but I didn't realize they had to use they could just use the surface of the moon. That's crazy.
Yeah, and I guess, lack of wind and stuff, I think they used the bottom of a crater to do it. Yeah. So a pretty undisturbed after that crater region.
Yeah. I wonder how much more powerful the laser has to be to just bounce it off the surface compared to one of the reflectors.
I do wonder because so the laser, I'm pretty sure wasn't invented until the late 50s, early 60s. So I can't imagine that laser would have been much stronger than what a standard laser pointer today would be.
Yeah. Yeah, that
But
was
yeah,
really, really early in the history because lasers have gotten so much more powerful since then. So, wow.
yeah, all sorts of problems that we get from laser pointers nowadays.
Wow, that's cool. It must be fun to do something like that. I always think of that. Remember that episode of The Big Bang Theory where they bounced a laser off of the moon on top of their apartment building or something? I
Wow.
always think of that episode when this gets brought up.
I mean, hey, I've heard lots of analysis of the science on that show. I'm sure you could do it at home. I feel like I've definitely heard of people who have pointed the lasers at the Apollo mirrors.
Yeah, we should try and get the observatory to do an experiment like that.
Do you think they'd let us with Pearson being so close by?
Oh, maybe not. That's a good point. Right, because there are laws about, you can't point a laser at a plane. That's a good point.
Yeah, and we do get a lot flying right overhead.
Yeah, we get them in the images a lot too.
I mean, that's always cool though. I'm never mad about that.
Oh yeah, I always like it. I like getting the plane and then I can look up what plane it is and where it's going.
Yeah.
Yeah, we had one of them last night. It was interesting. Yeah. All right, well, we should probably move on to our next history item, which is the launch of the Skylab space station. So Skylab is not a super well-known mission, but it was a very, very important mission. It was America's first space station. And Skylab was the space station that proved that humans can effectively live and work in orbit for extended periods of time. So it laid a lot of the groundwork for later missions like the International Space Station, and then a couple of the other space stations that we're going to be getting in the next few decades, hopefully, including one in lunar orbit. So it was a very important mission, and a lot about human spaceflight was learned because of the Skylab mission. So it launched on May 14th, 1973 from the Kennedy Space Center. It was on a Saturn V booster. And a lot of the time when we talk about launches, we say that the launches were fine and they didn't have any problems. But this Skylab launch was a little eventful. They had a couple issues. And the issues in this case were all caused by this micrometeoroid shield that was on Skylab. So this micrometeoroid shield was meant to shield the spacecraft from debris in space like micrometeoroids. And it also gave a lot of thermal protection to the spacecraft to keep it at a safe temperature for the astronauts that were going to live there. But the issue with this micrometeoroid shield is that it opened way too early, only about 63 seconds into the launch. And not only did this destroy the micrometeoroid shield, but it also caused a couple other problems, which was mainly that it tore off a solar array completely and then severely damaged another solar array. And all of these issues meant that, first of all, Skylab was too hot for astronauts to live there because it didn't have any thermal protection. And it also meant that it wasn't generating enough power because two of the solar panels were down. Despite these issues, NASA did launch a crew of astronauts to Skylab just like they had planned. They launched 10 days later. And most of these issues were up to the crew to fix with ground support. So that they did run into a couple issues while they were trying to fix the problems. They had issues with docking to Skylab, and then they also had a failed attempt to deploy one of the solar arrays during a spacewalk. But they were eventually able to fix all of the problems. And while it was definitely annoying and far from ideal, one of the things that this did prove was that it was possible for humans to repair a badly damaged space station while it was in orbit, which had never been done before. So it was a very useful thing, even though it was an accident and probably shouldn't have happened. But despite these early issues with Skylab, the mission overall was very successful. There was a ton of science that was done while it was in orbit. This included a bunch of observations of the Earth, which are, of course, very easy to do from something like Skylab. And also, some of the best science to come out of Skylab were observations of the sun using the Apollo telescope mount. So I think this was in the middle of a solar maximum. So the astronauts were able to observe a ton of solar flares from the sun using this Apollo telescope mount. So in addition to a lot of this science that was done on Skylab, a lot of the work that they did also had to do with figuring out what the best way was to live and work in microgravity for long periods of time. So one of the things that came out of this is that NASA figured out some of the best ways to build essential things that you need to live. So things like sleeping bags in the kitchen in space, exercise equipment, and even space toilets. They figured out what the best way to construct those were and the best way that they could be used in space. And the things that they learned about making those essential things that you need to live are still in use today on the International Space Station. And another interesting thing that came from this is that it also led to a lot of the standard practices for astronauts today. So there was apparently a bit of friction with the second Skylab crew when they were up there because the crew was saying that ground controllers were kind of expecting too much from them. So they were really stressed and had a lot of stuff going on and wasn't really going that well for them. So they basically just kind of took some of the things that they learned from that experience and started to implement, like changing the expectations of astronauts while they're in orbit in space to make sure that everyone is doing well. And of course, then there were a couple of other things that they got from this, including figuring out astronauts' exercise routines and diets, which are very important. It's very important to stay healthy in space. You need to exercise to make sure that, because being in microgravity affects your body in a lot of ways. So when you come back from microgravity, it can be quite the adjustment. So they were able to figure out, using this Skylab mission, how much doing exercise can help you when you get back to Earth and help you stay in good health while you're in space. So overall, a ton was learned from Skylab. So it was a very important mission. It was home to 3 crews in total, which each consisted of 3 astronauts. With the final crew departing Skylab in February of 1974, NASA had originally planned to send a few more crews to Skylab, but all of that fell through because of some financial issues. Now, while there were problems with the launch of Skylab, there were also problems with when Skylab's orbit decayed. NASA can, when a spacecraft is decommissioned, you can kind of drive it into the Earth's atmosphere, into a place where it will decay over an unpopulated area so that you don't crash into anyone or do any damage. And that's what NASA was planning to do with Skylab, but unfortunately, the orbit ended up decaying much earlier than planned and caused it to re-enter the Earth's atmosphere much earlier than expected, which happened in July 1979. NASA had attempted to make the best out of that situation and try and adjust the spacecraft so that pieces of it, when it broke up in the atmosphere, would avoid populated areas. But somebody made a math error and pieces of the spacecraft ended up landing in populated regions of Australia. Thankfully, nobody was hurt. So, but it's still very scary that happened. And hopefully NASA has learned its lesson about that for when the International Space Station is decommissioned, because we don't want that landing over populated areas like Skylab. But yeah, overall, this is a happy launch anniversary to Skylab on May 14th, 1973.
There's just so much to unpack with this one. Just to start, I can't believe that NASA sent astronauts up there after losing the shield.
Yeah, I guess they were just kind of like a risk assessment sort of thing, because the astronauts, if they ran into problems, could always just get in the capsule that they launched with and come back.
That's true.
Yeah, but still, I mean, losing the micrometeoroid shield. And when they launched, the spacecraft wasn't really doing so well. So I read in this article that they kind of had two options for positioning it, where they could either position it in a location where the maximum sunlight is hitting the spacecraft, where they'd get maximum power, or they could position it in a place where the temperature was like good for the astronauts. Because in the first position, it would be way too hot, but they'd be getting enough power. Or in the second position, they wouldn't be getting enough power, but the temperature would be okay. So the space station itself, like, it needed to be repaired before the crew could actually go into it. So that would definitely be a stressful mission to be on.
Yeah. Wow. They just sent them up there with like a manual, and they were like, you're on your own.
I think it was actually delayed because they had to do some extra training to figure out how to repair things. So, yeah.
I mean, you know what? Kudos to them for not backing out of it.
Yeah.
Once
apparently they were not happy though.
I can imagine, yeah.
Yeah, like they would come out of like communications blackouts and would be kind of ranting about what's going on, and had to be reminded that, you know, you're back in contact with the Earth, so maybe watch it a little. Because they seem quite frustrated with it.
Yeah, I mean, I feel like I would be too if I was being launched at like a hot room with no great contingency plan. I mean, I guess it all worked out, but that was, and then, you know, it's mishaps on launching it, which caused maybe some lucky Australian residents to pick up a little souvenir of Skylab fresh out of the atmosphere.
Yeah, I hope that doesn't happen with the ISS, because, I mean, that was pretty dangerous.
Hopefully they've learned in the 48 years, or
yeah,
not 48 years, but over 50.
Mm-hmm.
No, I'm lying. Sorry.
Okay.
Like 43 years that
it's around that, yeah.
Math is hard.
Yeah. Just like at least we're not the ones who are trying to figure out how to adjust a spacecraft so that it doesn't land on a populated area.
Yeah, don't put me on that crew, because we're looking at a Skylab repeat if I am.
Yeah. Like, don't ask me to do mental math, because half the time it's not going to go well.
Yeah, I'm not a physicist. Please, I'm going to stick to talking about everyone else's discoveries, and I'm going to stay on the side. I'll be a bystander.
Oh, yeah. Yeah. Yeah, well, you have another great This Week in History item for us, so go ahead.
Yeah. So we're sticking on the theme of missions, and about less than a year ago was when China's Tianwen-1 spacecraft landed its rover on Mars. So when launching Mars missions, agencies often try to take advantage of close approaches, which is when Mars is at its closest distance to Earth in its orbit. And this can help them conserve fuel. They set up efficient flight paths with short distances, and, you know, less flight time means less time for things to go wrong. So that's always a good thing. So close approaches for Mars happen every 2 years, but they follow an interesting pattern where the close approaches get really close for a little while, and then they get really far for a little while. So the most recent close approach was in October 2020. And this close approach opened up a launch window that would have had some really optimal launch times for any spacecraft that wanted to go to Mars in July 2020. And 3 agencies decided to take advantage of this window. And these were the United Arab Emirates, the Chinese Space Agency, and NASA in the US. So they all took advantage of this and all launched crafts to Mars, which was kind of a time crunch. They all launched within a few days, and, you know, they were on their way, speeding out of our atmosphere. So China's craft was the Tianwen-1, and after about 10 months of flight time, it landed its rover on Mars on May 14th, 2021. The Tianwen-1 mission actually consisted of 6 spacecraft, and these included several orbiting cameras, the main orbiter Tianwen-1, and a rover mission, which was called Zhurong. And this rover successfully soft landed itself on Mars, making China the third country to reach Mars and make connection with Earth, but only the second to successfully deploy the rover, the first being the United States, where NASA, as we all know, has several rovers already stationed and functional on Mars. So China was also the first agency to successfully deploy their Mars rover / lander on their very first mission attempt. So both the Soviet Union, back when they tried to launch their first Mars lander, and the US, their initial attempts at landing on Mars weren't as successful, whereas China's Tianwen-1 mission actually went really smoothly. So far, it's accomplishing all of its mission objectives, which are basically it wanted to go and study the geology, soil, and rock composition on Mars, as well as where's water located, the amount of water on the surface, and it also sets up a sample return mission for future planned missions. So the rover is actually picking up bits of dirt and soil as it, explores the surface, and it's going to store them away in little compartments for future missions planned for the 2030s to go back, pick it up, and send it back to Earth. So those missions will definitely be promising for us to examine Martian soil. So both the U.S. Perseverance rover and Tianwen were also the first two rovers to capture surface audio on Mars. And overall, this mission was a lot of firsts for China. The first successful rover mission on its maiden attempt, and some of the initial observations that were made were some of the first that were ever made. And so this was definitely one of the missions that marked a super successful launch period, because even the UAE's HOPE mission and NASA's Perseverance mission were both extremely successful. And so I guess a lot of planning that went into these over the early stages of COVID really paid off, because they all went very smoothly, especially Tianwen-1, and the mission continues to serve out its duties to this day, and it's going pretty well.
Yeah. It's quite remarkable that you have these three space agencies who were able to launch successfully missions during COVID, because everything was delayed with COVID. So it's pretty amazing to me that all three of them were actually able to do this despite COVID.
Yeah, I mean, NASA and I guess all the other space agencies, we've known that they do all their major work under extreme sterile conditions, like the clean room that the JWST was housed in for, like that could be a biohazard. But I guess it kind of paid off, because all those preparations that they were already doing, I guess they just had to continue them, and nothing would be amiss, because their clean rooms were about as close to sterile as a workplace can get without needing to be biologically sterile.
Yeah. Yeah, well, I also didn't realize here that you said it was 6 spacecrafts?
Yeah.
So what were the other ones? There's an orbiter and a rover.
So they had an orbiter and a rover. They also had, so the lander and the rover are technically considered 2 separate crafts.
Oh, okay.
And then the 3 others are a remote camera that was deployed from the lander along with the rover. And the last 2 were deployable cameras that actually went into orbit around Mars and were deployed from the Tianwen orbiter and took photos of Tianwen orbiting Mars. So they kind of had a little selfie moment.
Wow. That's crazy.
Yeah. I mean, it's amazing what this one launch window managed to do, considering it seemed weird weird, but in a good way, that attempts for years and years have been made by various agencies. And then this one launch window where everybody was, on a time crunch, they were like, okay, we need to get all these rovers out, all these spacecraft out, because the next time they would get a launch window this close would be like another 18 years or something. Yeah. And they managed to do it. They pulled it off.
Yeah. I mean, I guess that's just experience, because you said it was China and the UAE were both doing this for the first time, but I guess it's just experience even with other space agencies that when you do something for the very, very first time, you're going to run into issues, but it's very remarkable.
Yeah, and they've both also been doing other missions in the meantime. Mm-hmm. So while the US has been pretty squarely focused on Mars with all our previous rovers and craft going there, I do believe China has done a lot of work with the moon.
Yeah.
In the last few years. So they have, I guess once you're putting in the work to get to the moon, it's not that much of a stretch to put a rover on Mars.
Yeah, because you learn a lot when you do moon missions, and you can apply those to Mars missions as well.
Yeah, exactly.
Yeah. All right. Well, it is 9:30, so we should probably get going to our next history item, which is also a launch of a mission that included more than one spacecraft. This time, 2 different missions, not just 6 different spacecraft as a part of one, which was the launch of the Planck and Herschel space telescopes. These 2 space telescopes were launched together on May 14th, 2009, from Europe's spaceport in Kourou, French Guiana. They launched stacked on top of each other on an Ariane 5 rocket. And after the launch, when they were on their way to the second Lagrange point where they spent their mission lifetimes, the 2 of them separated and kind of went on their own paths. But the 2 of them did launch together May 14th, 2009. So the 2 different telescopes they did very different things, but they were both very successful missions. So the Herschel Telescope, which is the one that I'll talk about first, was a 3.5-meter telescope which observed the far infrared and submillimeter wavelengths. At the time, this was the largest infrared space telescope that had ever launched, and was also the first space telescope that would observe submillimeter wavelengths from space. The main science goals for Herschel were basically to observe galaxy formation, observe star formation, and some of the very early stages of star formation specifically that aren't accessible to other kinds of telescopes, like telescopes that observe optical and UV light. There's too much dust surrounding some of these early star-forming regions that optical and UV light, you can't see anything using those. You have to use a far infrared or submillimeter telescope to observe those wavelengths. So Herschel made many great discoveries over its lifetime. So this included discoveries on bodies in our solar system. So this included studying the atmospheres of planets, comets, and moons. So one of the things that it did in that respect is it found evidence of molecular oxygen in space, which was actually the second time that had ever been done. And it also found evidence of water in our solar system. It also found a new stage of star formation and observed these high redshift galaxies, which are some of the first galaxies that had ever formed in our universe. So it did a lot of work in many different regions, even making some observations on protoplanetary disks that would eventually form planets and solar systems, and observing supermassive black holes. So it did so many things in so many different areas of astrophysics. It was really a great telescope. And then the second mission that launched with Herschel was the Planck mission, which was a different kind of mission, but it was just as successful as Herschel. Planck was a radio telescope which observed the cosmic microwave background radiation, and that's the radiation that was just left over from the Big Bang. It's the earliest, it's the furthest thing in the universe that we can see. It's at about 380,000 years after the Big Bang. So this is kind of the limit for what we can observe in the history of the universe, is this cosmic microwave background radiation. So what Planck did is it created this new map of the cosmic microwave background over the entire sky, which was the most detailed map that had ever been created. There were a couple space telescopes that had gone and made these observations before, but they just hadn't been as detailed as the Planck observations. Scientists from the Planck team then used the maps that Planck created to understand how the universe had evolved over time. So they can use this map to determine the age of the universe and some important constants like the Hubble constant, the matter density of the universe. So basically how much baryonic matter there is. So that's the normal matter that we're made of. And also determine how much dark matter and dark energy there is in the universe. And in addition to updating all of those constants, the measurements from Planck were also able to confirm that there were a few anomalies that had been seen in previous maps. These anomalies from previous telescopes had been largely ignored just because there were some doubts about whether or not that was actually there or it was just some kind of artifact in the data. But the observations from Planck were high enough resolution to show that these aren't just some artifacts in the data. This is an actual anomaly that's there and it's real. So the first Planck all-sky image was released in 2013. Then there was another one later in 2015, which incorporated all of the data taken by the spacecraft over its lifetime. And finally, that in 2018, there was yet another set of results released from Planck, which was just reprocessing of some of the other data that had been released previously, which was just something that was required for more accurate results. So overall, both of the telescopes are now, they're both decommissioned. Herschel was decommissioned in June 2013, and then Planck in October 2013. And in both cases, it was just because the missions ran out of the coolant that they need to be able to operate properly. That was May 14th, 2009, the launch of two very successful space telescopes, Planck and Herschel.
Wow. Call me maybe a dummy for not realizing this, but I didn't realize that we had so many successful missions currently at L2, or currently or recently at L2.
Yeah, I didn't realize that either until I started looking at JWST at L2. But yeah, it's a really, really good spot to put spacecraft because it's so far away from the Earth. So you can avoid like massive regions of sky that the Earth and Moon block. So it's a really good spot to put them.
Yeah, and I guess having done all these past missions to L2 before, not even L2, even the L1 has several spacecraft. Mm-hmm. I guess it just made it that much easier. Like they really did set it up and open the door for JWST.
Yeah. So Planck and Herschel actually launched from the same place on the same rocket that JWST launched.
Yeah, the Ariane 5.
Yeah.
So this is they're definitely, doing some of the heavy lifting for JWST, and I guess we can credit a little bit to them as to why JWST's launch went so smoothly. Oh yeah. Yeah, the Ariane 5 is such a reliable rocket. I think it's only ever had one disaster, which was like decades ago. So it's a really reliable. Why fix it if it's not broken?
Yeah. Did an absolutely fantastic job with Webb.
Yeah, that was possibly one of the most seamless launches I've ever seen. And yeah. I would have to assume that, being so close temporally, like the ground crew must have a lot of significant overlap between these two, the Planck and Herschel and JWST.
Mm-hmm. Yeah. So, two amazing missions that were launched on the same rocket to the same place as JWST. All right, we should probably get going because we're getting a little short on time here. But for those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Alan I. Carswell Observatory at York University in Toronto, Ontario, Canada. You're listening to Gagan and myself, Sana, currently discussing some astronomy history. Go to observatory.yorku.ca to join our online public viewing chat room to ask us any questions you may have and to see some live images taken by our observatory team with our 1-meter telescope. You can also connect with us on Twitter or Instagram with the handle @York Observatory and on Facebook at Alan I. Carswell OBS. So we have a few interesting news stories for you tonight, but before we get to that, we do have a couple of reminders that we need to talk about first. So the first one is the lunar eclipse that's coming up on the 15th and 16th. So that's Sunday and Monday of next week. The eclipse is going to start at 10:28 p.m. on Sunday. It'll reach totality at 12:11 a.m. and then will end at 1:55 a.m. on Monday. This is going to be one of those what's it called, the blood red eclipses. So a very easy one to observe. Just go outside and look at the moon. You don't even need any telescopes, but those are always fun to have. The observatory is going to be hosting an in-person event for this. It's currently just for students, faculty, and staff of York University. The event is free, but you have to sign up ahead of time. Tickets will be available on our website very soon. We will also be doing a live stream of the event on our YouTube channel, which will include live images of the moon from our 40-centimeter telescope over on our YouTube channel, YorkU Observatory. And finally, we will also be broadcasting live from the Killarney Park Dark Sky site at the same time, of course, weather permitting. So make sure to remember to take a look at this great eclipse on Sunday next week, and please join us if you can.
Yeah, I really hope the weather is okay. I know we're having a lot of a lucky stretch right now with clear skies, so hopefully that stretches to Sunday night.
I really hope so, because it would be very upsetting if we had to miss this.
Yeah. Okay, so I have a couple more reminders as well. So this Wednesday, the observatory will be hosting an in-person tour. So sign up is online at observatory.yorku.ca, and this is open to students at York University. We have entire public yet, but hopefully as COVID regulations continue to ramp down, they will become available at some point. Live imaging will continue from Killarney Park Observatory, and we will be on the Arboretum, which is on top of the William Smalls parking garage this week. Another reminder is that this week we have several good International Space Station passes, so please head over to spotthestation.nasa.gov, and you can find your location on the website, and it'll let you know when the ISS is passing overhead, how you can see it, where it's going, and how long you can see it for. So I would definitely recommend checking this out. It's really cool to see the ISS passing overhead. It's really bright, almost as bright as a planet, and it travels really fast. You can't miss it. If you look up at the right time, you'll see a space station going by pretty fast. It kind of just looks like a star, a big star, but if you have binoculars or a telescope that you can point it that way, definitely worth seeing. So check it out.
I always love looking at the International Space Station because you're like looking in the direction where you know it's going to be and you can't see it, and then it just sort of pops up out of nowhere. And
yeah,
it always surprises me when that happens. It really shouldn't, but it always does, and it's a really fun thing to watch.
Yeah, I love especially when it transits. The images that come out of ISS transits of even the sun and the moon, they're amazing.
Oh, yeah. Yeah, all right. So moving on to our news items for tonight. This first one is about these newfound auroras on Mars. So auroras that we see here on Earth and on many, many other planets are the result of charged particles from the sun in solar wind interacting with particles in a planet's atmosphere, which then emit different colors of light that we see as aurora. They happen on many, many different planets, including Mars. However, Mars has a fairly weak and patchy magnetic field, so these aurorae also tend to be weak and patchy and stay pretty localized. There are a few kinds of normal aurorae that have been discovered on Mars. Some of them are these discrete aurora, which are patchy kind of aurorae that happen over areas on the Martian surface where there's deposits of magnetic minerals in the planet. And then there's also these diffuse aurora, which are these very faint aurora that stretch across the entire planet. And these only happen during solar storms when large amounts of solar wind are hitting the planet and creating the aurora. But recently, there was a new kind of aurora discovered called a sinuous discrete aurora, which is a very weird one, and it's very odd that this was actually observed. Scientists were not really expecting this. And this is just because it's sort of a combination of the other two kinds of aurora. So it's stronger, like these discrete aurora, but is also very, very long, like some of these diffuse aurora. So it has these fairly bright and long tendrils that stretch over large portions of the planet and are relatively strong. So this is something that really wasn't expected to be discovered on Mars. Scientists currently have a couple ideas about what could cause these auroras, but they don't really know for sure at this point. They're currently saying that it's likely to be similar in origin to these diffuse aurora, which are caused by solar storms. But the sinuous discrete aurora, of course, were unexpected just because of how large and how strong they were. So what the going kind of guess for what causes these is that when some very, very strong solar wind hits the Martian atmosphere, it just creates a lot of very strong aurorae, well, relatively strong for Mars, that stretches over a large portion of the planet, and you just have to have a very strong, some strong solar wind that hits it for this to happen. So ultimately, in order to determine what causes these sinuous aurora, scientists need more observations of any kind of aurorae on Mars. It's possible that they can get some of these observations in archival data from past Mars orbiters like Mars Express and MAVEN. But it's also likely that the orbiter that found these aurora are going to be able to observe more of them in the future. So these discoveries came from the UAE's HOPE Mars orbiter, which, like Gagan mentioned earlier, launched only last year. And this is, again, also the UAE's first interplanetary mission to Mars. This HOPE Mars looking in the direction where you know it's going to be and you can't see it, and then it just sort of pops up out of nowhere. And
yeah,
it always surprises me when that happens. It really shouldn't, but it always does, and it's a really fun thing to watch.
Yeah, I love especially when it transits. The images that come out of ISS transits of even the sun and the moon, they're amazing.
Oh yeah. Yeah, all right. So moving on to our news items for tonight. This first one is about these newfound auroras on Mars. So auroras that we see here on Earth and on many, many other planets are the result of charged particles from the sun in solar wind interacting with particles in a planet's atmosphere, which then emit different colors of light that we see as aurora. They happen on many, many different planets, including Mars. However, Mars has a fairly weak and patchy magnetic field, so these aurorae also tend to be weak and patchy and stay pretty localized. There are a few kinds of normal aurorae that have been discovered on Mars.
Because, morphology-wise, they kind of feel the same way, just long tendrils of aurorae that cover large expanses of the sky.
Mm-hmm.
But that's really cool. I didn't know that Mars had such large kind of planet-wide aurorae.
Yeah, it's pretty cool.
Yeah, definitely. And I hope maybe the rovers are able to get images of it at some point, even because their imaging capacity is so much greater than what it used to be.
Yeah, that would be really cool. I have seen these really great pictures of the Martian night sky from the surface of Mars. That was pretty cool.
Yeah.
So it would be awesome to get pictures of aurorae from the surface.
Yeah, that would be awesome.
Mm-hmm. Yeah.
Well, I think I have the next.
Yep, it's off to you for your
go ahead.
next. It's off to you for your next news item.
All right. So we've talked about planetary formation on York Universe. We talk about it all the time. I feel like almost every time I'm on here, one of the news stories for This Week in History is about an exoplanet or how a planet is forming. And today is going to be no different. So what we're talking about today is a new gas giant that we're seeing forming in a star around a star about 530 light years from Earth. And it's currently making waves in its protoplanetary disk. So exoplanet studies, of course, are all the rage recently, and certain stars seem to be of more interest than others, and AB Auriga is no different. It's one of the active stars where the protoplanetary disk is actually face on to Earth, so we can observe it in all its glory. We can see the full circle instead of seeing the protoplanetary disk edge on, and this makes observations, I wouldn't say easy, but a lot easier than it would be with other stars. So its protoplanetary disk is currently making some planetary babies, including a gas giant that's estimated to be 9 times the mass of Jupiter. And this star has been of interest, and observations on AB Auriga have spanned almost 13 years, allowing us to really witness the changes and the development of the protoplanetary disk around the star, as well as the planets inside this protoplanetary disk. So earlier on in its observations, we did see a star forming kind of closer to the planet, and so we called that AB Auriga A. And now this current gas giant planet that we're talking about, called AB Auriga B, I know, super creative, is actually of interest because it's twice as far from AB Auriga than Pluto is to our sun. So it is extremely far from its sun, basically. And the other thing that it's doing is it's kind of leading us to think about new theories of planetary development, most notably something called disk instability. So disk referring to the protoplanetary disk. Disk instability refers to when large clumps of gas and dust that are floating around this star in a disk, they clump up and then collapse under the weight of their own gravity, or they collapse because of their own gravity into these dense regions of matter, and these dense regions of matter eventually form planets. So there have been a lot of theories for planet formation in the past, and there's like a nebular theory for planet formation, especially with our own solar system having 8 planets plus a bunch of stragglers out past Neptune. Ariella would kill me if I say that, our old coordinator. She is staunchly Team Pluto for a planet. But we do get a lot of theories that come up about how the solar system formed and how the protoplanetary disks evolved. And because these processes take thousands and thousands of years, it's really hard to observe them. So to be able to have one relatively this close to Earth, in the midst of planet formation that we can observe over long periods of time, is really a real treat. And we're really seeing this planet come together before our eyes. Although I guess it's slower than watching grass grow, basically. So the observations are slowly but surely taking form, and we might see a lot more of disk instability in the future in terms of how planets form and even how our solar system formed.
Oh, that's really cool.
Yeah, I mean, I know when we take our early astronomy classes, we hear a lot about planet formation, and because it's really hard to see planet formation because most of protoplanetary disks are obscured by the stars that they kind of surround, it's difficult to observe. And a lot of new exoplanet observation technology is helping us out with that. So I'm glad we're getting this kind of insight now.
Yeah. I know JWST is going to have a coronagraph on board, so I wonder if they're going to observe this.
I hope they do, because they have the Hubble on it every once in a while. So 13 years ago, they had the Hubble on this star. They have the Hubble on it again. They had it again observing it in April. So that's where these new observations are coming from. But yeah, it's definitely a promising star study for exoplanet formation. And there's several that we can see that are face on that allow us to observe planet formation. And because all these stars are so different and part of different systems, we can see them at different stages of their development. So we have some stars that are in early protoplanet disks, and then other stars that are in late disks where you just have a couple of almost formed planets and then some light dust floating around in between them. So it's really cool to see them in different stages.
Yeah, between JWST and Nancy Grace Roman, which is going to have the best coronagraph which has ever been launched into space, it's going to be really interesting to see what happens with this field in the next few years.
Yeah, Lagrange giving us all the data. We love it.
Yep. All right, so with our next couple of minutes, we have one last short news story, which is unfortunately kind of a sad one this time. So this is about the Sophia Telescope, which is a really, really awesome telescope. It's a 2.5-meter infrared telescope that's mounted on a very heavily modified Boeing 747. So Sophia can just fly above the atmosphere to get infrared observations, since those can't really be done from the ground. Well, Sophia has been operating for many years. It had its first flight on May 26th in 2010. But it is now going to be shutting down. It's a joint project between NASA and a partner, the German Aerospace Center. And while it has done a lot of work and has been a very successful telescope, last year, the Decadal Survey, Decadal Survey just does a review of the current state of astronomy and astrophysics in the United States, and just basically tries to provide a path forward for American astronomy so that they can keep making good discoveries. Space agencies tend to listen to the recommendations made by the Decadal Survey Committee because they do provide a lot of useful feedback on the state of astronomy. And when they released their 2020 Decadal Survey last year, they recommended that Sophia be shut down, basically just saying that it's really not worth the operating costs. The scientific return of the telescope is limited compared to how much money that NASA and their partner has to pour into the telescope. So it's really not worth it, and that it should be shut down so that the money that they spend on Sophia can be spent on some other projects that they had recommended as more worthy of funding than Sophia. So unfortunately, Sophia is going to be shut down by the end of this year. It's currently in a 3-year mission extension. And when that is complete, the observatory will be decommissioned. That mission is set to end on September 30th, 2022. So that will be around its last, it's going to be closing down no later than that date, which is pretty sad. But when the Decadal Survey announced this last year, I kind of knew this was coming, but still very sad that Sophia is being shut down because it's such a cool telescope.
Yeah, absolutely.
Yeah. Unfortunately, but oh well. They recommended a lot of really cool telescopes, and between that and JWST, it's still going to be great moving forward in astronomy in the next 10 years. Right, well, that's the top of the hour here. So you've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Gagan and myself, Sana. Stay tuned because it is Science Night in Canada. Coming up next is Western World, Quirks and Quarks, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse and check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.
From AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.
Look,
Being a host is never easy. All the prep